So the next couple lessons that you will have in pre-calc are on polar coordinates. So what you have learned so far has always been rectangular coordinates. So when we talk about rectangular coordinates, those are the points X and Y, your horizontal distance, vertical distance. But that isn't the only way you could give directions to get there. So we also have what is called polar coordinates, and polar coordinates have a point, but their point is r theta, not xy. The r represents the radius or your distance from the origin, and your theta is your angle from the positive x-axis. Okay, so we should be able to plot them. So if you think of your unit circle, so your unit circle, if you were looking here, your pi over 4 would lie here. So you think, okay, where's my angle? And then I want to go to that angle and go out a radius of 2. So that would be our point A. Point B is 2 pi over 3. So if we think of 2 pi over 3, we are over here. This is 2 pi over 3. And we are out 4 units from the center. Now, the next one's 3 pi over 2. Well, we know 3 pi over 2 is down on that negative y-axis, but it says go to that angle, but then it wants a negative radius. So a negative radius is going to pop that point back up. So that point then would be located here. Now, what you notice by doing that is that location can have many different coordinates. So when you're dealing with rectangular coordinates, they're very specific. You're going to the right 3, up 4. But when you're dealing with polar coordinates, the same point could have multiple coordinates. The last one, negative 5 pi over 4. Remember, a negative angle goes backwards. So negative 5 pi over 4 would be located up here. And we are 1 up. So that would be our point D. So you should be able to plot them and realize that the first number that listed is your R, or your distance from the origin. And the next one is your theta, which is your angle from the positive x-axis. Okay. But we also should be able to go the other direction. We should be able to tell, okay, what's the coordinate of this point? But like I just said, you could have multiple answers that would give you the same coordinate. So this first one, point A. So it is at our angle pi over 4. And it is 1, 2, 3, 4, 5 units away from the origin. So we would say 5 comma pi over 4. Point B, we're going to look at is 3 units from the origin, and we would be at 2 pi over 3. C would be at 4 pi over 3, and it is 2 units away. And our last point, and this one's interesting because you have the point D, and you could write this, it is 1, 2, 3, 4 units away at an angle of 0, or you could write that as 4 comma 2 pi. Now, all of these could be written as multiple ones, but that's just an easy one that you can see could be written in 2 different ways. Now, we should be able to convert then polar coordinates and change them to rectangular coordinates. Okay, so as you can see the picture over here, you have X and Y, and we have a point here. So X would be your distance and your horizontal direction. Y is your distance and your vertical direction. You notice your R, which is your distance from your origin, which really is your hypotenuse of that triangle that you're forming, and your theta. So by trigonometry, we could say that the cosine of theta is adjacent over hypotenuse, which is X over R. So then you can see how they would solve to get X to be R times sine of theta. You could do the same thing with the Y. Sine of theta is Y over R, and solve that for Y, which is going to give us our formula that we have here for Y. So we need to plot or plug in our values. So our radius is 2. So we'd have x is 2. We'd have cosine of pi over 4. Well, cosine of pi over 4, 45 degrees, is square root of 2 over 2. So we'd have 2 times square root of 2 over 2, which is going to give me the square root of 2. So that would be my x value. My y value then would be 2 times the sine of pi over 4. So that would be 2 times, again, the sine of pi over 4 is also the square root of 2 over 2, which is going to give me square root of 2. So I have square root of 2 comma square root of 2. You do have to be careful when you are using these formulas on whether these values are positive or negative, depending on what quadrant you're located in. So if you think in terms of this one, we're 2 units away from the origin at pi over 4. So we should be over here. So we should see then that both our x and y coordinates should be positive. Whereas in other quadrants, you might want to just double check. You should also be able to convert the other direction. So if you are given a point, you should be able to convert to r theta. So if you're given a rectangular point, convert to polar. So what you would need for this is you need your Pythagorean theorem, because that's going to help us find our r. You need to use inverse tangent to find your theta. So if we have the point 2, 1, we would say r squared is equal to 2 squared plus 1 squared. So then r would be the square root of 5. Now, to find our angle would be the inverse tangent of y over x. So y in this case is 1, x is 2. So you can use your calculator to do that and find when is tangent 1/2. So I don't have one handy. Oh, yes, I do. So I'm going to do inverse tangent of 1/2. So, and if they want it to degrees, make sure you're in degree mode. If they want it in radians, make sure they're in radian mode. So if I am in radian mode, my angle would be 0.4636. So that's just a short introduction to polar coordinates. We will be doing more with the equations and some graphing of them later this week. Have a good day.